Since the beginning of our company 37 years ago, we have been delivering plant engineering solutions to clients in Japan and around the world. The accumulation of our engineering experiences with many types of plants and technical know-how has allowed us to evolve our expertise over the years and become a provider of total engineering solutions. Not only do we deliver full turnkey solutions, we are also flexible and responsive to the needs and requirements particular to each client, and ensure that each plant engineering project is designed and engineered to their satisfaction. We are an authority on engineering plants and provide a complete range of engineering services for numerous kinds of plants in different fields. We have experience and expertise spanning nuclear, thermal, geothermal and hydroelectric power plants, and in a range of industrial plants such as chemical, steel, semiconductor, and waste treatment facilities, as well as others. Our global engineering services include full turnkey engineering solutions and offer a complete package of services that encompass consulting, site survey, designing and engineering the architectural, civil, mechanical and electrical work, procurement, site supervision, coordination of vendors and scheduling, construction, and aftercare maintenance services. We also provide specific expertise for any number of particular engineering aspects of a plant, such as fault analysis detection and troubleshooting. With years of experience and know-how, the Plant Engineering Business Group provides total solutions and total client satisfaction. Under Consulting Engineering, Nippon Koei Company Limited, Japan, in association with PT Indra Karya, PT Yodya Karya, PT Wiratman and Associates, or N. hydraulic turbine generator. Thus, the Wonorejo project will produce an annual electric energy of 31.7 Greenwich hour to the public in the East Java. Detailed drawings, literature, and instructions before proceeding with the manufacture of the equipment, Toshiba Engineering Corporation performed the design data, design analysis, the design calculations in typewritten book-bound form, detailed specifications, general assembly drawings and details, and manufacturer's descriptive literature to demonstrate fully that all parts will conform with the requirements. Each operational unit fully assembled as far as practicable in the workshop and measured to ensure that all component parts are properly manufactured and that all design dimensions, tolerances, and clearances have been obtained. The employer and the engineer, entitled at all reasonable times during manufacture to inspect, examine, and test on the manufacturer's premises the materials and workmanship, and check the progress of manufacture of all plant to be supplied under the contract. Witness tests of the plants invite the employer's personnel to witness tests of major items of the plants in the manufacturer's works to observe and finalize at the manufacturer's work all the design matters before manufacturing. For employer's personnel for their installation, supervision, and reliable operation and maintenance of the generating equipment. After testing and inspection, all items of the plant and equipment shall be adequately packed and protected for shipment and storage. The crane provided the box girder, indoor, traveling type, electrically operated, and provided with one trolley-mounted main hoist and auxiliary hoist. The rated capacity of the main hoist is not less than 5% in excess of that required to enable it to lift the largest and heaviest components to be lifted in the power plant. It is anticipated that the heaviest single lift will be the generator rotor and shaft. It is required that a crane capacity of 25 ton. The main hoist equipped with a combination lifting eye and sister hook. A 5-ton auxiliary hoist is mounted in the trolley with the main hoist. The elevation of the bottom surface, the crane hooks at their highest position at elevation 107.00 meters. The span, hook limits, clearances, and maximum lifts compatible with the power plant arrangement and dimensions. Crane rails is 10.0 meters on centers. The total length of runway is approximately 25 meters and straight. The hoist shall raise, lower, and hold in any position a test load of 125% of its rated capacity. Second hoisting position shall raise this load, and it shall not lower in the first hoisting position. Trolley and crane shall transport at full speed or as directed along the full runway length with a test load of 125% rated capacity. Before testing, the hoist is operated under light load for a period of time equivalent to several hours of continuous operation to run in the gearing and to ensure that all parts are properly lubricated. After this run-in period, the crane inspected to see that all parts have remained in alignment and that no excessive wear has occurred. Survey of draft tube foundation marking center line and support setting. Installation of draft tube. Checkpoint, center, elevation, and level. Concrete of draft tube by civil contractor, plug and welding of grout holes. PT test on welding. Survey of spiral case foundation and temporary setting of upper draft tube. Assembly spiral case to bottom ring and installation. Checkpoint, center, elevation, and level. Installation of spiral case, extension pipe, and compound ring. Temporary setting of 4 or more guide vanes and head cover. Centering and fixing of bottom ring. Checkpoint, center, elevation and level of spiral case. Center, elevation and inclination of inlet and dimension of spiral case. Center roundness and level of bottom ring. Installation of pit liner. Dimension of pit liner and PT on weld. Installation of inlet valve, gate shaft base plates and embedded pipes around spiral case and pit liner, hydraulic pressure test and PT on weld. Concrete around spiral case and pit liner by others, plug and welding of grout holes, PT test on weld. Dimensional check of spiral case, checkpoints, center, elevation and inclination of spiral case inlet, and dimension spiral case level and roundness of bottom ring and level of head cover. Dimension between head cover and bottom ring. Temporary installation of shaft seal housing and bearing housing. 1, 2. Installation of lower bearing bracket. Installation of stator and upper bearing bracket. Centering of turbine and generator, center, roundness, and level. After centering turbine and generator, ramming and dowel holes. After ramming of dowel holes, dismantling of head cover, lower bearing bracket, and upper bearing bracket. Installation of guide vanes and runner shaft. Installation of head cover, shaft seal housing, bearing housing, servo motor, gate operating ring, and gate operating mechanism parts. Installation of lower bearing bracket and lower generator rotor, upper bearing bracket and intermediate shaft. Shaft run out, installation of guide vane operating mechanism, shaft seal guide bearing, generator housing and air duct. Installation of penstock pipe and concrete by civil contractor. The turbine will be put into service under levels and heads of water system as follows. Water levels in the reservoir. Flood water level, elevation 185.00 meters. Maximum water level, elevation 183.0 meters. Weighted average water level, elevation 173.0 meters. Minimum water level, elevation 153.0 meters. Water levels at tail race. Flood water level, elevation 111.0 meters. Rated water level, operation at rated output, elevation 109.37 meters. Minimum water level, no flow, elevation 108.50 meters. Heads. Maximum gross head 74.5 meters. Maximum net head 71.93 meters. Rated head 61.20 meters. Minimum net head 41.5 meters. Setting elevation of distributor. The center line of the turbine distributor is placed at elevation 108.40 meters above sea level. Type and rating of the turbine is the vertical shaft, single runner, Francis type, and shall have an output of not less than 6,500 kilowatts at full guide vane opening. When operating at the rated speed of 500 revolutions per minute under a net head of 61.20 meters. Means provided to limit turbine output at the head above 61.20 meters to the rate output of 6,500 kilowatts. The best efficiency is desired when operating at 500 rounds per minute under a net head of 61.20 meters. The draft tube of the elbow type can be made of steel liner with not less than 12 millimeters thick, can be supplied to a point 3,000 millimeters downstream from the vertical center line of the turbine. Beyond this portion, the draft tube will be formed with concrete to the shape as designed, but clear opening and draft tube outlet shall be 3,200 millimeters in width and 1,900 millimeters in height. A sufficient number of leveling screws or jacks and anchor rods with turnbuckles is provided for centering, leveling, and securely holding the liner in correct position during assembly, and placing of concrete will be placed by the civil contractor according to the contractor's instructions. The spiral case will be embedded in concrete and therefore shall be provided with stiffeners and anchorages sufficient to ensure so that no deformation will take place during concreting. There shall also be provided a sufficient number of leveling screws or jacks, lugs and anchor rods with turnbuckles for supporting and holding the case during placing of concrete. Placed by civil contractor. The runner be made of a low-carbon stainless steel with 13% of chromium and 4% or more of nickel and integrally casted. The runner be equipped with stainless steel replaceable wearing rings. The intermediate turbine shaft is the proper length to connect with the generator shaft and to disassemble the turbine without disassembling of the generator, and have an integrally forged flanked half coupling on its upper end for connection to a similar coupling on the lower end of the generator shaft. The turbine guide bearing is self-oil lubricated segmental or cylindrical type, complete with oil reservoir and water cooling oils, and designed to withstand safely and without damage the natural retardation of the turbine and generator from the maximum runway speed to rest without the use of the generator brakes. The turbine guide bearing also consists of a bearing support of housing and a removable Babbitt-Lind bearing shell surrounded by an oil reservoir. The guide vanes designed so that the guide vanes will have a tendency to inherently close up to non-load opening without causing an excessive pressure rise in the spiral case in the event of failure of governor oil pressure. Top of each guide vane stem for readily adjusting and maintaining the adjustment of each guide vane in the mid position between the head cover and bottom ring without disturbing the guide vane assembly. Each guide vane stem connected by linkage to the regulating ring. A friction device provided on each guide vane to prevent a disengaged guide vane from interfering the operation of remainder on the regulating gear in the event of blockage of the guide vane. The operation link also be restrained so that it does not affect the operation of the regulating gear. All parts subject to relative movements is provided with bushings and washer of greaseless lubrication system. The turbine equipped with a single double-acting servo motor provided with adequate safeguard to prevent lifting of regulating rising. The servo motor provided with a sufficient capacity to operate the guide vanes under all hydraulic conditions with the minimum oil pressure from the governor oil system. The governor be complete with speed signal generator or SSG, electro-hydraulic actuator, regulator, associated mechanism, cabinets, oil piping to the pressure oil supply system, foundation bolts, and accessories required to make a complete unit for regulating the speed of the turbine. The governor have sufficient capacity to supply the oil required to the servo motor to completely open or close the guide vanes within a minimum time of 4.0 seconds for any operating head. The governor suitable for manual control at the governor cabinet and for remote electrical control of the turbine from the main control panel in the control room. It shall also be suitable for automatic synchronizing. The turbine control panel consists of group status indicator, group fault indicator, solenoid valves, limit switches, auxiliary relays, pressure gauges, dial-type thermometers, pressure actuated switches, control switches, etc. All interconnecting piping and valves between the various parts of the governor system, including connections between turbine guide vane servo motor, inlet valve servo motor, the pressure oil tank, and sump tank. The type of inlet valve is biplane type with inside diameter of 1.4 meters. The inlet valve operated by pressure oil to be supplied from the pressure oil supply system of governor. The inlet valve provided with the pressure oil operated bypass valve. The bypass valve needle type and have sufficient sectional area to ensure balanced pressure in the spiral case and the penstock. A stop valve be provided on the penstock side of bypass valve. The inlet valve designed and constructed as to operate smoothly without causing excessive vibration and dangerous pressure fluctuation in the penstock, and capable of opening and closing within 120 seconds, including bypass valve operation under the maximum gross head of 74.5 meters, when passing the maximum flow corresponding to full output of the turbine. A combined motor control center provided for auxiliary equipment such as pressure oil pumps, air compressors, main strainers, and leakage oil pump of the turbine generator unit. A combined motor control center also provide for the drainage pumps and other station common equipment. Type and rating. The generator type of three-phase, vertical shaft, conventional or suspended type synchronous generator with a salient pole revolving field. The cooling system is the outlet duct air ventilation type. The generator rate as follows. Duty type, continuous running day. Rated output, 7,000 kilovolts ampere. Rated voltage, 6,600 volts. Rated current, 612 ampere. Rated frequency, 50 Hz. Rated power factor, 0.9 lagging. The speed of the generator is 500 revolutions per minute. The generator designed for speed rise up to 155% of the rated speed and withstand the maximum runway speed of 990 rounds per minute for not less than 5 minutes. Direction of rotation clockwise. The stator frame supported on and grouted to the power plant foundation. The round frame will sit on sole plates laid a concrete beam in the power plant foundation with the generator housing. The concrete beam will form part of the generator floor. The core of the generator built up with high-grade, non-aging, thin, laminated silicon steel, each lamination coated on both sides after punching, with an insulating varnish or other material to minimize eddy current losses. The laminations adequately keyed or dovetailed to the stator frame and securely held in place by clamping flanges at each end to prevent looseness of laminations on the outer ends of the slots and the top and bottom of the stator. After all static part of generator and turbine has been assembled, and before lowering rotating part of generator turbine, centering work of generator through turbine is performed. The pole piece is built up of thin steel laminations secured by bolts passing through supporting end plates. The pole piece is attached to the rim of the rotor spider. After the pole pieces are assembled, the slots in the rim of the rotor fitted accurately to the dovetails so as to secure adequate bearing. The pole pieces shall be held firmly in position by means of tapered keys, and the keys bracket locked in position on both sides of the rotor by plates, so as to prevent the keys from coming out in event they cannot drop out should one or more of the keys become loose. Brackets placed between adjacent pole pieces to brace the windings and prevent them from becoming distorted when subjected to the centrifugal forces due to runway speed. Electrical connections between field coils of flexible type and supported sufficiently to eliminate mechanical failure due to vibrations, thermal expansions and contractions, or stresses from centrifugal forces throughout the speed range of the generator. Insulating collars provided at the top and bottom of each field coil and adequately supported at all points. The inner or bottom insulating collar supported in such a manner as to compensate for shrinkage in the insulation and to maintain adequate pressure on the field coil. The damper winding sufficiently supported to eliminate mechanical failure due to vibrations, thermal expansion and contraction, or stresses from centrifugal forces throughout the speed range of the generator, including maximum overspeed. The brakes designed to serve as hydraulic jacks to lift the generator rotor and rotating parts of the turbine a sufficient distance to provide for removal or adjustment of the thrust bearings, and all affected part of the generator designed to provide for vertical movements of this amount without the necessity of any disassembly of such parts. The brushless excitation system installed for the generator. The brushless excitation system consists of an alternating current exciter or AC exciter, rotating rectifiers, and excitation transformer, field switch, voltage regulating equipment, and other accessories. The AC exciter designed to withstand the maximum runway speed of the turbine for 5 minutes without damage. Three-phase, 7,000 kilowatts ampere, 6.6 per 20 kilovolts main transformer with an off-circuit tap changer, which is intended to be connected directly to the generator with neutral grounding resistor of 500 ohms, 25 amperes. The transformer connection of the main transformer by YND5 of IEC 76-1 and the neutral of the 20 kilovolts star-connected winding brought out for resistor grounding. The transformers is designed for a frequency of 50 Hz. The continuous rated power of both windings of the main transformer 7,000 kilovolts ampere under natural oil circulation and natural air cooling operation at any tappings. A shock recorder filled on top the transformer's tank to monitor any rough handling which might cause the transformer to be damaged. Indoor switchgear consists 6.6 kilovolt switchgear, 20 kilovolts switchgear, low voltage switchgear. All switchgears are designed for a frequency of 50 Hz. The 6.6 kilovolt switchgear installed for the generator circuit and station service transformer circuit. The switchgear constructed by RIT frame, floor standing structure completely enclosed by sheet steel. The 20 kilovolt switchgear installed for the secondary circuit of the main transformer 20 kilovolts distribution lines and station service transformer circuits. The low voltage switchgear installed for the secondary circuit of the 150 kilovolts ampere station service transformer. Set of main control boards for consisting of programmable controller electrical protective relays, measuring transducer automatic synchronizing device manual, synchronizing panel data logging, and event recording systems AC panels, DC panel. Battery charger, water level gauging system for intake dam water level, tail race water level. The supervisory control system consists functions for generating unit automatic or manual control, indoor switch charger control, supervision of water levels, data logging and event recording. The installation on the free access floater in the control room. They shall be of attractive design and utility arrangement to provide the best convenience for the required control and customary operation. The programmable controllers perform the required unit automatic control, indication, protection and alarm management for the generation unit, station service circuit 20 kilovolt switchgear, and communicate with data logging and event recording system. One set automatic synchronizing device provided for automatic synchronizing the main generators to the 20 kilovolts power system. The automatic synchronizing device static design consisting of an automatic synchronizer, a voltage balance relay, and a frequency matching device. Interlocks provided to ensure that only one generator is available for automatic synchronizing operation at a time. The automatic synchronizing control include automatic control of turbine speed, generator and circuit breaker, closing for synchronizing operation with a minimum disturbance to the generator and the power system. The synchronized scope provided with suitable measure to protect the driving mechanism against overrating due to unexpectedly long synchronizing operation. AC and DC panel shall be supplied and installed in the relay room for AC and 110 volts DC control power distribution to the equipment and instruments. 2 water level gauging systems supplied and installed at the intake dam and the powerhouse tail race to monitor their water levels in the control room. Installation emergency diesel generator set complete with all appurtenances and necessary spare parts to supply control, motor, oil pumps and drainage pumps. The rate continuous output capacity of the diesel generator not less than 100 kilowatts at power factor 0.8. The diesel generator installed in the emergency engine room. The non-turbocharged diesel engine, the full compression ignition vertical cylinder, single acting, 4-cycle, 1,500 rounds per minute, solid injection, water cooling type with air-cooled radiator. Governing system is electronic type governor. It will maintain the suitable engine speed according to loads. Engine start and stop carried out by automatically and manually started by DC starting motor. In the case of engine trouble, engine will be automatically shut down and locked out to prevent to restart. The distribution line route length of the line is approximately 24.6 kilometers from Wonorejo Power Station to existing Tulungagung substation according to the drawing. The route is decided only study on the map and carry out the route survey, topographic check survey, and prepare the drawing for actual route map, plan, and profile of the distribution line. Install 1 pair of radio telephone equipment, complete with all appurtenances for the communication between the Wonorejo power station and the existing Tulungagung substation. After installation works completed, commissioning tests could not be performed due to the penstock is not yet installed and the impounding is not yet proceeded. For 1.5 years of long-term storage is performed for countermeasure the power plant. In this period, every 3 months our designers perform inspection and countermeasure to all items of the equipment, and especially for turbine and generating equipments, and temporary energizing 20 kilovolts distribution line from Tulungagung substation up to terminal pole in Wonorejo power station for prevention of theft during long-term storage. Perform for all items where applicable to ensure that the equipment has been correctly installed, all necessary adjustments and settings made, and that the items are in sound condition to run under load. All equipments are subject to the general inspection for construction, wiring, and cable connection. All electrical equipments are subject to installation resistance measurement. All control and protective circuits are subject to control and protective sequential operation tests. All meters, gauges, instruments, temperature relays, and temperature detectors are subject to calibration check. Following the stationary functional test and watering into the turbine and waterway, the rotational test shall demonstrate that the works are properly installed, fully operational, free from vibration and leakage, correctly adjusted, and that the performance guarantees are met. It is necessary to cooperate works for watering and dewatering of turbine and waterway and carry out the water tightness test for the machinery. During the rotational test, it ensures, where applicable, that the observations and measurements are made and recorded as follows: water levels at reservoir and tailwater, generator output, voltage, current and reactive power, generator field voltage and current, unit speed, frequency, pressures at penstock, spiral case, runner back and draft tube, turbine servo motor stroke, oil pressure and level in oil pressure tank, air pressure in air reservoir, temperatures at bearings, coolers and windings, deformations of head covers and bearing supports, power swing, vibrations at turbine head cover and generator brackets, shaft runouts at turbine guide bearing, shaft coupling, and generator guide bearing, hydraulic thrust, noise levels, action of draft tube air admission devices, ambient temperature, cooling water temperature. During the rotational test, it also checked that the auxiliary equipment has sufficient capacity and has operating characteristics to meet the operating requirements of the generating equipment, main transformer, and switchgear. And it coursed A. No load test, B. Loading test. After rotational tests for the unit of the machinery and equipment has been completed, and the rechecking the alignment of moving parts, adjustment of bearing and tightness of bolted connections to ensure that the unit is in proper operating conditions. After completion of the rotational test and final inspection of the plants, the reliability run shall follow to satisfy the employer that all components are in satisfactory condition. The generating equipment is subject to the reliability test to operate at rated speed, normal voltage, and outputs within the specific limits under the operating conditions of the station, either continuously or intermittently, without failure and undue interruption of any kind resulting from defect of the plant for a period of 500 hours before taking over. Operating guidance service. The contractor shall provide instructions and training to the employer's operating personnel at the site after the date of issue of the taking over certificates. The instructions and training is aiming at the reliable routine operation and maintenance of all equipment supplied under contract. Toshiba Engineering dispatched the operation instructors separately from his erection, testing, and maintenance staff, continuously generating